All right, everyone, welcome to the second video of this lesson. In this video, we're going to learn about differentiation rules for logarithmic functions with bases other than e. So let's get started. All right, very similar to how our last video started, I'm just going to give us this derivative. So the derivative when we have log base a of x. All right, so that is just 1 over x and then natural log of a. And again, I want to show you guys what is this going to look like when we have the chain rule. So with the chain rule, we're going to have the derivative of log base a of u. So that's going to be 1 over u natural log of a times u prime. And actually, in a lot of cases, it's going to be easier just to write u prime up here in your numerator. So I'm going to write that there as well. So that's an equal sign. So u prime over u natural log of a. So with those two ideas, what I want to do is apply this with the natural logs. Okay, just don't forget that natural log just means log base e. So I know we say log a lot as an abbreviation for natural log, but really it means log base e. Okay, and log is really just an abbreviation for log base 10. All right, so let's go ahead and find this derivative just very simply how we were doing it in our last lesson. So we see natural log, so it's just going to be 1 over sine of 3x times cosine of 3x times 3. So f prime of x is going to be 3 cosine of 3x over sine of 3x. What's nice about that is cosine over sine is cotangent, so we get 3 cotangent of 3x. And that is actually a very nice looking answer. All right, so let's go ahead and apply this new rule that we had from before. And we're going to find, okay, what is f of x or f prime of x when f of x equals the natural log of sine of 3x. Okay, so f prime of x is going to be 1 over the inside, so sine of 3x times natural log of e, okay, times cosine of 3x times 3, okay? And so just like it was in our last video, natural log of e is equal to 1. So keep that in mind. So we never wrote that in our previous lesson because it was always there, but we didn't have to write it because natural log of e is just 1. So if we rewrite this, we get 3 cosine of 3x over sine of 3x, which simplifies to be 3 cotangent of 3x. The exact same thing that we got a second ago. Okay, 3 cotangent of 3x. But with an extra step, because we simplified that natural log of e, which is something that we didn't really have to do before. All right, but we just don't want to forget that that's there moving forward. All right, so let's go through several examples here. When we have log base 2 of 4x, all right, so we're just going to go 1, or guess f prime of x equals 1 over 4x, so the inside, times the natural log of 2 times the derivative of 4x because of our chain rule. So the derivative of 4x is 4. So this is going to be, what I can do with that is those 4's actually divide out. So we end up with 1 over x natural log of 2. And that is going to be our final answer. So look for things to actually divide out here pretty consistently. Okay. Moving on to our next problem where we have g of x. We have g prime of x is going to be 1 over the inside, which is sine of x, times the natural log of the base. Okay, and our base here is going to be 3 times the derivative of the inside because of the chain rule, so cosine of x. Okay, and that's what we have. So we have cosine of x over sine of x, natural log of 3, and cosine over sine is cotangent x over the natural log of 3. So always going to be simplifying these as we can. All right, looks like we're flying through at a pretty good pace here. So moving over here to h of x, we are going to have h prime of x equal to 1 over cosine of 3x times the natural log of 5. And then we have to take the derivative of the inside, and we are going to have a chain rule there. So that is going to be negative sine of 3x times 3. All right, let's simplify this as much as we can. So negative 3 sine of 3x over cosine of 3x times the natural log of 5. And we have sine over cosine, so we can simplify that to be negative 3 tangent of 3x over the natural log of 5. Okay, so again, we're going to have pretty simplistic quotient identities here with some trig, but just go ahead and keep applying those. It's going to simplify some of these problems in the end, and that's probably, you're going to probably see this answer on the multiple choice as opposed to that first line. All right, moving over here to p of x, and we have log of 2 to the 3x, and I have an exponential and a logarithmic. Okay, so we got to put both of our lessons together here, which is going to be kind of tough, but no big deal. So p prime of x is going to be 1 over, just keep in mind, no base here means that the base is going to be 10. So this is a common log, so just keep that in mind. And then the inside is 2 to the 3x, natural log of 10. All right. And then I need to multiply by the derivative of the inside. So that derivative is going to be the exact same, 2 to the 3x, natural log of 2 times 3, because of the chain rule. Okay, and we just went over that in our previous video. So if you're kind of watching this out of order, I went over those exponential derivatives before. Now, what I notice is I get 2 to the 3x, 2 to the 3x, one's in the numerator, one's in the denominator, so those are going to divide out. And so I have 3 natural log of 2 over natural log of 10. Okay, and also I'm remembering an exponential rule that this 3 goes into that top right there as an exponent. So 2 to the third is going to be natural log of 8 over the natural log of 10. And I also recall another exponential rule, which is going to be when our logs are the same base, so log base c is what we have, and they're being divided b over a, so the inside is b, the inside of the denominator is a, then that is just going to be log base a of b. That's just the change of base formula. Okay, so what I can do with this is I'm going to have log base 10 of 8, which is equal to the common log of 8. And that would be my final answer. So that's actually a pretty nice thing to happen in this video, because this is a lot of rules that you might forget, that I don't want us to kind of forget, and that they're going to spout up every once in a while. But yeah, these are little minute details of algebra that you're going to want to take a look at. All right, now let's look into even more complex algebraic examples. Okay, got a few of those here in this video that are going to be pretty big algebraic examples. Okay, so we have k prime of x. Okay, and so it's going to be 1 over the square root of x squared minus 1 times the natural log of 7. That's the way that starts. Now, don't forget, when we take this derivative, I'm going to think about it as x squared minus 1 to the 1/2. So that's going to be a chain rule, 1 over 2, and I get x squared minus 1 to the negative 1/2. All right, so when I simplify this a little bit, I am going to get 1 over square root x squared minus 1. This 2 right here goes to the front, okay? And I still have natural log of 7, and I'm going to keep that denominator going. because a negative exponent means that goes into my denominator. X squared minus 1 goes down there. And I have two x squared minus 1s getting multiplied together. Okay. And actually, I noticed that I brought down the 1/2, but I actually forgot here a chain rule. So times 2x. So I'm going to actually make sure I add that 2x to my numerator right there. If anybody caught that mistake in that chain rule, again, you now see your teacher forgetting some of those things as I'm getting into the rhythm of just like rules inside of rules inside of rules. So if you caught that mistake, make sure you let me know in the comments below. All right, so let's see what ends up happening with this. These 2's are going to end up dividing out. Okay, that's really nice. And then I get x in my numerator, and in my denominator, these square roots, since they have the same radicand, they are going to basically just go away. So I have x squared minus 1 times natural log of 7. So x over x squared minus 1 times the natural log of 7. And that is going to be our final answer for k prime of x. It's a really cool question. All right, now let's come over here to q of x. Oh gosh. So we have a pretty big derivative. There's going to be, I believe there's probably going to be fractions inside of fractions, some complex fractions. So really want to stay organized in our work here. So q prime of x is going to be 1 over the inside. So 3x over x minus 1, okay, times the natural log of 3. Okay, now we want the derivative of the inside. So I'm going to multiply that here. The derivative of the inside is going to be low, so x minus 1, d high, so 3x, or sorry, 3 minus 3x times 1, and then square the bottom, x minus 1 squared. All right, there is a lot to simplify here. So I'm going to do a few things at once. I am going to think about, okay, if I distribute this, I get 3x minus 3x. So those are going to cancel out, and I'll still have the minus 3 in the numerator. So in my numerator, I'll have minus 3. Okay, now here my denominator, I still have 3x. And what I notice here is that I have x minus 1. That's in my denominator of the denominator, okay? And that is going to cancel out with one of these x minus 1s. But now, since it canceled out, or divided out technically, I'm going to actually have an x minus 1 in my numerator of the denominator. So it just becomes on the same level. So that's going to look like 3x times x minus 1. If that's a lot that's happening right there, I know this is going to be really algebraic heavy. I'm just trying to keep everything confined into these boxes in our notes. So I'm doing a lot of like mental arithmetic, what I would call messy math. But if you want to see this worked out in more fine detail, go ahead, ask me or ask another teacher if you're being assigned these videos, and make sure you actually get that help to look at how all of these things are being divided out and canceled. Okay, so moving forward, we still have that natural log of 3 in our denominator. Okay, the other thing I see happening here is that those 3's are going to divide out now. So my final answer is going to be negative 1 over x times x minus 1 natural log of 3. And that would be my final answer in this case, which is honestly pretty good considering how we went from this best to that. All right. So now we have a couple more questions. So let's keep chugging along. And another chain rule happening here. So we're going to go p prime of x equals 1 over the inside. So sine of x squared times natural log of our base, which is 2, times the derivative of the inside. And we have a chain rule happening there. So the derivative of sine is cosine of x squared times the derivative of the inside of that. So times 2x. All right. So I have, if I simplify this a little bit, I'll have 2x cosine of x squared over sine of x squared natural log of 2. And what I notice here is that we have cosine over sine. The inside is the exact same. So cosine over sine is going to be cotangent. So this is going to say 2x cotangent of x squared over the natural log of 2. And so we can see, again, we have these trig identities that we're going to keep applying. We have the chain rule that we're going to keep applying. I told you this is going to be pretty algebraic heavy, but we're almost there. We're almost to the end. And our final question is going to be, for what values of x will the graph of h of x equals log base 2 of that quotient have a tangent line whose slope is 5/2? So in our last video, we had a normal line whose slope was something. So this one is, we're looking for an h prime equal to 5/2. All right, so let's figure out h prime of x. And just like our last video, we're going to finish this problem on our calculator. All right, so h prime of x is going to be 1 over that inside part. So x over 2x plus 1 times natural log of 2. Now we had the derivative of the inside, which would be a quotient rule. So low 2x plus 1 d high, which is just 1, minus high, so x d low, so that's going to be times 2, all over 2x plus 1 squared. And if you remember some of those patterns that were happening before, we're going to have a 2x plus 1 cancel out, divide out with that 2x plus 1 that's in the numerator or the denominator. I know these complex fractions can be kind of frustrating to kind of keep track, but stay organized in your work. And up here, again, I have a negative 2x and a 2x that are going to divide out. So my numerator says 1 over x times 2x plus 1. Just one of those is not squared now, times the natural log of 2. And what we want to do is set this equal to 5/2. Okay, so when is this equal to 5/2? So let's go ahead and grab our calculator now. And we're going to have 5 over 2. And right here, I'm going to put in a big fraction. And that's going to say 1 over x times 2x plus 1 times the natural log of 2. Okay. And what I want to figure out are these intersection points. So let's graph this and see what we've got happening. Okay, so there's 5/2. And it looks like I have 2 points of intersection. So we are going to do second calc, intersect, and I need to move this one over. So let me actually hit that again. Second calc, intersect. And my first curve is right here. So enter, enter, enter. And that guess should pop here. So that's the one I'm looking at. And that x value is approximately negative 0.8425. Okay. And now I want to find the second intersection point. So I'm going to do second calc. All right. So now I hit intersect. And I'm going to drag this over to the right side now, because I want that cursor to be on the right side of the intersect so I can get that one. So hit enter. And now I have that new x value. You can see that the little spider moved to that new x value. And so x this time is approximately 0.3425. All right, so those are going to be our two values for x. And it does say in the question, let me minimize our calculator. It does say in the question, for what value or values? So if there are multiple values, and I know in our homework for today that it says on particular intervals, make sure you give me the answer on those intervals, all right? Or else you're going to be missing out on points because you're not giving me every point of intersection or every time where x, the derivative of h of x is going to equal 5/2. All right, so that is actually going to conclude, I think, a very good lesson, very good add-on to what we had in our previous video, in our previous lesson as well, about the natural log and exponential functions e to the x. Because we just want to keep in mind, okay, what is that base is a little bit different. And it just adds one little tiny thing to our function. So as you move on to those practice problems in a second, some of those, again, are going to be algebraic heavy, but I have gone over every single thing that you could possibly see here. And I just want you guys to keep that in mind, that you are very prepared calculus students. And as long as you continue to master all of our lessons moving forward, you're going to be great in May. If you do have any questions about this or any of my other videos, please reach out to me. I'm Mr. Hernandez, and this was Mr. Hernandez Teaches.